Hello all. So in the previous lecture, we have seen what do you mean by what is this functional dependency, and also we have seen different keys. We have seen super key, primary key, and all. Now, in the previous lecture, we have also seen what is this normal form. So, what do you mean by this normalization? So, normalization it is a process of analyzing the given relation schemas based on their functional dependencies and primary keys, and we need to achieve some desirable properties like minimize that redundancy, minimize that insertion, deletion, and updation anomalies. So for that, we perform some test on these relations. So what all those formalized tests that should be performed is will be studied in this lecture. Okay, so this lecture is mainly about normal forms, database design, and in this we will be learning about normal forms, and this is actually the formal way to design relations. So this is actually the formal way to design relations. So this is the outline of this lecture. We'll learn about first normal form, second normal form, full functional dependency, third normal form, and in the third normal form, we'll learn about transitive dependency also. So before going into this, we'll recap what is a normal form. So the normal form of a relation of it or a table refers to the highest normal form condition that it meets, and this indicates the degree to which it has been normalized. So if we say a relation is in third normal form, we mean that it is the highest normalized table, that is it is satisfying all the third normal form conditions. So first normal form means there are some conditions that should be satisfied. If that relation is satisfying those conditions, then we can say that this table is in, or this relation is in first normal form. If it is satisfying some other condition, we will say that this is in second normal form. If it's satisfying some other condition, we'll say that it is in third normal form. So what are those conditions will be learned in this lecture. So this is very important. So first thing, we will learn about first normal form. So first normal form is actually considered to be part of the definition of a relation. It is actually considered to be part of a definition of a relation. So it disallows, first normal form disallows composite attributes. So there should not be any composite attribute. So you should understand what is this composite attribute. So for example, address, it is a composite attribute. It consists of house number, apartment number, like that. There will be different fields. So we should not have composite attributes. We should try to avoid those composite attributes in relations. Then it disallows multi-valued attributes. So we have already seen what is this multi-valued attributes. There will be multiple values for the same attribute. For example, a department location. It may be located in, or a project location. It may be located in different projects. Sorry, a department may be located in different locations. So if so, multiple values will be given for that multi-valued attribute. Then there should not be any nested relation. Nested relation means a relation inside another relation. That is, attributes whose values for an individual tuple are non-atomic. Non-atomic means indivisible, divisible values. So it is atomic means indivisible, which cannot be divided further. So if the attributes whose values for an individual tuple are non-atomic, then it is known as nested relation. So it can be considered as a relation or a table inside another table. So we'll see how to normalize it. So most relational database management systems allow only those relations to be defined that are in first normal form. So most of the relational database management system automatically has to satisfy this normal form. It is automatically included in the thing. So we cannot enter any data without satisfying this first normal form. So we cannot create tables without this satisfying, without we cannot enter data into the tables without satisfying this first normal form in most of the relational database management system. But we will learn about this first normal form also. Theoretically, what is this first normal form? So we will see how to normalization. Here we will take an example. So here we have a department and we have D number, D manager assistant, and D locations also is also included in the department relation. Now D locations, department locations, it is a multi-valued attribute because a department may be located in more than one location. So department locations is a multi-valued attribute. So if you take this state, database state, you can see that research department, it is department 5 and the manager is this one, and it is located in three different locations. So within braces means it is a multi-valued attribute. So we have already studied all these things when we learned about attributes. So department locations, it is a multi-valued attribute here, multi-valued attribute. So it is a multi-valued attribute in this case. So as per the definition of first normal form, it disallows this multi-valued attributes. So how to remove this multi-valued attribute? That is, we should not show this kind of thing. Only if we take a tuple, if we take a row, it should represent only a single thing. But if you see this thing, it is representing three different department locations. So it is not atomic value, it is non-atomic value here. So how can we change it into a single thing? So the one way to remove this multi-valued attribute is to separate this research into three rows. So three rows, it will be split like this. So research, now it is Bel Air, then Sugarland and Hauser. So all these have been separated into three different rows. Now if you see each value is single valued. Now it is that condition is satisfied. So first this table is in first normal form because there are no multi-valued attributes, only atomic attributes are there. Okay, this is one way to normalize it into first normal form. So this table is not in first normal form because it has multi-valued attributes. In order to remove this multi-valued attribute, we separate it into three rows. So this is one way to remove this thing. And second way we can remove this multi-valued attribute. This is one way. So this is normalized now. But the problem is there with this table because we have a redundancy problem. Because research is repeated three times. Similarly, this D manager SSN is also repeated three times. So there is a problem here. So there is a problem here. This, even though this is in first normal form, there is a redundancy problem. Then another way to normalize the same table is that if we know the maximum number of department locations that will happen, we can split this D locations into three different attributes. If we say that one department can be at most located in three different locations or five different locations, if we specify that thing, then we can split this department locations attribute like department location 1, then another column we will add department location 2, then another column we will add department location 3, then another column department location 4. Like that we will add 5 columns. If we specify that at most 5 locations can be given to a particular department, then we will have 5 columns. So in that case we have to specify the maximum number of locations that a department can function. So if in that case we can change this attribute to department location 1, then department location 2. Like that we will give 3 different column names, and one inside one it will be Bel Air, in this another one it will be Sugarland, and the other one it will be Hausen. Like that we can enter. So but the problem with that thing is there will be more null values. So we have learned in informal guidelines we should minimize the null values. So in that way also we can normalize it to remove this multi-valued attribute. But the problem is there because we might have more null values, because administration department is located in Stafford only, but the other 4 columns it will be null value. Similarly, headquarters is located in Hausen only, so the other 4 columns we will have null values. So that should also be avoided. So one way is to split into 3 rows, or we can split it into 3 columns. three, if we know that at most we can have three different locations for each department. So that is another way to reduce this. Then actual normalization, so this is we have redundancy problem. In the second method we have null value problem. Now we can decompose this into, so in order to normalize into first normal form, there is another way, and that is a way that should be adopted. So what we have to do is, this is the problem, this delocations is the problem. Now if we remove this attribute, when there is a multivalued attribute, we remove this from this table. So the table becomes d name, d number and d manager assistant. So this is the department table, and we remove d locations into another table, and in that table this d locations and the primary key of this table will be there. So d number and d locations will be there. So we will be normalizing like this. So d number, department table will become d number, name, d number, d manager assistant. Another new relation will be formed with the d location and the primary key of this table, that is d number. Okay, now we have split into like this. So here there won't be any redundancy problem or null value problem. So this way we can normalize. So in top-down design, what we do is, when that relation is not in a particular normal form, what we have to do is we try to decompose it, or we try to split that table or that relation. So here the problem is with the delocation attribute. So we remove this from this table and we form it another relation which consists of this delocation and the primary key of this table, that is d number. So that we will get like this. Department is this table and department location is another table. So in this way we can normalize into first normal form. Now these two relations are in first normal form. Okay. So this relation will be changed to these two relations. Okay. So this is known as decomposition. So this is by decomposition, normalization by decomposition. Next, we have another example. We have M projects relation where the attributes are SSN, comma E name, and within braces we have projects, and we have P number and hours. So this is actually a nested relation, because this is a relation inside another relation, because an employee can work in n number of projects. He may not be working on a particular project, he will be working on more than one project. So it is a multi-valued attribute. So if you see the database state, you can see the Smith John is working on two projects, and the hours he is working 32.5 and 7.5. Now English Joyce, she is also working on two different projects. Now Wong Franklin, he is working on four different projects. So this is known as nested relation, because it is another relation. This is another relation inside this relation. So this is a separate relation and it is inside this relation itself. Now what you have to do, so this is not in first normal form. So this relation is not in first normal form. Now we have to make it to first normal form. So what we have to do is, we have to remove this nested relation. Or if it is multivalued, what we have done in the multivalued case is the same thing we have to do here. So these two attributes is the problem. So this project's P numbers, comma hours is the problem in this thing. So what we have to do is, P numbers and P hours is the problem. So we remove these two attributes, and what we have to do, we have to take the primary key of this table, that is SSN. So we will split it into SSN, P number and P hours into a separate table. So SSN and P number combination will form the primary key of this table, and the other table will be SSN comma E name. So we split it into two. We make it SSN comma E name as one table, and the second table will be P name, hours and the primary key, that is SSN of this table. So SSN comma P number comma hours. Now here the combination of SSN and P number will become the primary key of this table. Now these two relations are in first normal form. These two relations are in first normal form. This relation is not in first normal form. This has been split into two relations, and we got two relations that are in first normal form. So this is known as normalization. So we decompose the relation. So this is actually a nested relation. In order to show that we have included this this name is included here. Actually, this name is not there. We have only 4 attributes in this M project: SSN, E name, P number, hours. Now this actually belongs to another relation, projects. So we split it into 2. So these 2 attributes is the problem attribute. We are removing this from this table. So another example we can see for nested relation. So this is another example. So candidate. So a candidate will have SSN. The name will be there. Then he might have worked for some other company. So his job history will be there. So he might have worked for that company. His highest position will be there. Then he might have worked for several different companies. He might have worked for several different companies, and he might have held several different positions, and he might have several different salaries also. So every year he might have different salaries. So if you want to store the information about all these things, this can be called a recursive relationship also. So actually, so there are nesting of nesting. So here, within candidate, he will have different job history. So he will be working on several different companies. It is actually multi-valued attribute. Multi-valued company and highest position is multi-valued, and within that, his salary history is also multi-valued. That is, year maximum salary will be every year he will be having different salary. So these 2 attributes are also multivalued. So we have 2 multivalued attributes. So how to normalize this? So again, we have to follow the same procedure. So first table, it will be SSN and name. We have to remove all the other attributes. So we will make it relation candidate. We will name it as candidate 1 SSN comma name, and here SSN is the primary key. Now what we have to do, we have to remove this thing. So we will make another table. You can give any name. We have named this candidate underscore job underscore history. And what you have to do, you have to take the primary key of this table, SSN. Then we have to take company and highest position. So this combination will be the primary key of this table. Then we have to take salary history. So we will make candidate underscore salary underscore history. So it will contain the primary key of this table, SSN, then the primary key of this table, SSN company, then year of this table, and this combination will be the primary key of this table, and maximum salary will be another attribute. So in this way, we can normalize this relation. So what we have to do is we have to remove those multi-valued attributes. We have to separately form new relations, and there we have to add the previous table key. So we add the SSN primary key here. Here we have added the primary key of this thing, that is SSN and company is added here, and another attribute of this one will be year. Year will be added here. Okay, in this way we can normalize this nested relation. Then there is another chance where there can be more than one multi-value attribute. So for example, here a person with a social security number, he can have 2 or more cars. Then he can have 2 or more phone numbers also. So this is multi-valued attribute. We have more than one multi-valued attribute. A person may have 2 or more cars or 2 or more phone numbers also. So in this case, what we have to do? So in this case, first way we can do is the following the above previous strategy, we can follow like this. So we have to rename this, and we have to include all these attributes together in a relation, and this combination will form the primary key of this table. But there is a problem with this, because in certain cases there will be redundant information will be stored, or maybe null values will be there. Maybe person may not be having this phone number, or car may not be there. So in those cases there will be some problem. So in order to the right way to do this is to split into 2 relations like this: SSN number, then car license number in one table, and another table will store SSN number and phone number together. So this way we can separate it into 2 tables. So one way we can do this combination, but there is a problem with this thing, because redundancy will be there. There will be some redundancy information will be stored here. So in order to remove that redundancy, it is better to split it into two tables like this. P1 SSN number, car license number. This will form a key. These two together will form the key. And another way is to form another relation with P2 SS number and phone number. And the combination will form the primary key of this table. So we have two relations from this. So this is now more than one multi-valued attribute example. So we have split it into two, and this is in first normal form now. Next, it is what is meant by second normal form. So that is all about first normal form. So it uses the concepts of functional dependency and primary key. So you will see the definition. Before going into the second normal form, we have to define a few things. Prime attribute. What do you mean by this prime attribute? Prime attribute, it is an attribute that is a member of the primary key. So earlier we have defined that prime attribute is a member of any of the candidate keys. But we will redefine this later. Now we will redefine that prime attribute like this: an attribute that is a member of the primary key. So prime attribute means it is a member of the primary key. If it is any one of the attributes in the primary key, then we can call it as prime attribute. Any other attributes will be considered as non-prime attribute. Okay. Then full functional dependency. A functional dependency x to y is fully functional dependent where removal of any attribute from x means that functional dependency does not hold anymore. So if you remove any attribute from x, and if this functional dependency still holds, then it means it is not fully functional dependent. We will see an example, then you will understand. Before going into that, full functional dependency, so this is the definition actually for any attribute a element x, which is a means a single attribute, that is in x. If you remove that a from x minus a, then x minus a, and if it is x minus a to y holds, then it is not fully functional dependent. If the x minus a to y does not hold, then it is fully functional dependent. So a functional dependency x to y is a partial dependency. We call it as partial dependency if some attribute a element x can be removed from x and the dependency still holds. Before going into the definition, we will see an example. So here this is an example for partial dependency. Here the key M project is a relation. Here the key is the SSN comma P number. This combination is the key of this relation. Now we have a full functional dependency. Ours is fully functionally dependent on SSN and project number together. But ename, it is dependent only on SSN. So it is having partial dependency. So we call it as partial dependency. Similarly, P name and P location is partially dependent on P number because P name and P location does not depend on SSN. So it is fully functional dependent on P number alone. So it is partially dependent on the key of this relation, or E name is partially dependent on the key of this relation. Okay. So ours is fully functional dependent on SSN comma P number. Now we will go back to the definition. So fully functional dependent means for any attribute A element, if we remove this, then that determinacy or the dependency won't be there. A functional dependent x to y is partial dependency if some attribute A element x can be removed from x and the dependency still holds. If you remove like this A, x minus A, if you remove A and still the dependency is there, then it is partial dependency. So it is a partial dependency. So because if you remove this, even when we have already defined this is the key. So all other attributes should fully functional dependent will be functional dependent on the key of this thing. So E name is functional dependent on SSN and P number. P name is functional dependent on SSN and P number. P location is functional dependent on SSN and P number because this combination is the key. But there is a partial dependency because E name is partially dependent on the key of this relation. E name is partially dependent on the key. So E name is dependent only on SSN. Similarly, P name and P location is dependent on P number alone. So this is known as partial dependency. So partial dependency on the key. So SSN comma P number is ours. It is a fully functional dependency since neither SSN to ours nor P number to ours hold. Here SSN to comma P number to E name is not a fully functional dependency. It is called partial dependency since SSN to E name also holds. Now we will see what is second normal form. So second normal form states that if relation schema R is in second normal form if every non-prime attribute A in R is fully functionally dependent on the primary key. So you have to remember that here prime attribute means all the attributes that are part of primary key. Okay, we have to consider only primary key. So if every non-prime attribute A in R is fully functionally dependent on the key of R, on the primary key of this R. So if it is not in second normal form, we can decompose it into 2NF relations via the process of 2NF normalization or second normalization. So what we have to do is if that table is not in second normal form, we have to decompose or we have to split it into 2 or 3 relations. So this is an example. So in this this table is not in second normal form because so as per definition, every non-prime attribute in R is fully functional dependent on the primary key. So if we check this thing, non-prime attributes here is ours, E name, P name and P location. Here the prime attributes are SSN and P number. So ours, it is fully functionally dependent on SSN and P number because this combination is needed to determine the hours. But E name, it is dependent on SSN alone. So there is a partial dependency. Similarly, P name and P location. So it is dependent on P number alone. So it is having a partial dependency. Now this is so it is not in second normal form. Now we have to make it into second normal form. For that we have to normalize it. We have to decompose it. So decomposition means we have to make it fully functionally dependent. So what you have to do? So SSN P number and ours will form one table. So ours is now fully functional dependent on SSN and P numbers. That is okay. Now A name and SSN, we will take this functional dependency separately and form another table or another relation. Now E name is fully functional dependent on SSN or the primary key of this table. Now this is perfect. Now we will remove this P name, P location and P number into another table. Now P name and P location is fully functional dependent on P number. So these two relations are in second normal form. So it is satisfying the condition because ours is fully functional dependent on the key, E name is fully functional dependent on the key, and P name and P location is fully functional dependent on the key. That is, all non-prime attributes are fully functional on the key, functional dependent on the key. So every non-prime attribute A in R is fully functional dependent on the key. So this table becomes three different relations and each relation is in second normal form. So this relation is in third normal form, second normal form, this is in second normal form and this is also in second normal form. Next you will see third normal form. So definition of third normal form, before going into third normal form, we have to define what is transitive functional dependency. So transitive functional dependency means it is a functional dependency X to Z that can be derived from two functional dependencies X to Y and Y to Z. That is, Y is functional dependent on X and Z is functional dependent on Y. Then that means X and Z are functional dependent. That is, SZ is functional dependent on X to Z holds. So then this is known as transitive dependency. Transitive dependency. Okay. So X to Y and Y to Z. This means X to Z. So and another condition is there, and this Y is not a candidate key or not a subset of any key of R. So this Y is some attribute or set of attributes. So it should not be a candidate key of that R. So we will see an example for this transitive dependency. So if we see this table, we have transitive dependency. Here SSN is a primary key. Now we have dependency SSN to D number And from D number we have a dependency D name, and from D number we have a another dependency D manager SSN. So there are two transitive dependency, that is SSN to D number to D manager SSN, and SSN to D number to D name, another transitive dependency. So SSN to D manager SSN, it is transitive functional dependency, because we have SSN to D number and D number to D manager SSN. So this is known as transitive dependency. So this holds SSN to D number and D number to D manager SSN holds. So this is transitive dependency. Here D number is the Y attribute. So SSN to D manager SSN holds. This is transitive dependency. SSN to E name, it is not transitive dependency. There is no attribute for that, since there is no set of attributes X where SSN to X and X to E name is there. So SSN to X and X to E name is not there. So there is no transitive dependency between SSN to E name. Then we will define what is, so this you should understand what is this transitive dependency. So what is third normal form? So a relation schema R is in third normal form or 3NF if it is in 2NF. So it should be in 2NF. And no non-prime attribute, here also no non-prime attribute A in R is transitively dependent on the primary key. So all the non-prime attributes should be fully functional dependent on the primary key. That is, no non-prime attribute should be transitively dependent on the primary key. So if it is not in third normal form, R can be decomposed into 3NF relations by the process of 3NF normalization. Again, the same thing we will be doing. So note, we have to note one more thing. If there is a dependency like this, X to Y and Y to Z with X as a primary key. Here, if X is a primary key, we consider this a problem only if Y is not a candidate key. So this is only if this transitive, there is a transitive dependency. This transitive dependency becomes a problem here if only Y is not a candidate key. If Y is a candidate key, then there is no problem, because transitive dependency is not at all a problem here. So if Y is a primary, if Y is a candidate key you have already studied. So Y is a candidate key, then this is not a problem. Transitive dependency is not a problem. So when Y is a candidate key, there is no problem with the transitive dependency. We can simply ignore it. So for example, we will see an example, SSN, comma, EM number, comma, salary. Here SSN to EM number and EM number to salary is there. So there is a functional dependency SSN to M number. Similarly, M number to salary is there. So there is a transitive dependency SSN to salary. But it is not a problem here, because employee number, it is a candidate key. So this transitive dependency is not a problem in this relation. So this becomes a problem only if this M number is not a candidate key. So that is the thing we have to note it. Okay, so as per third normal form, no non-prime attribute A in R is transitively dependent on the primary key. Okay, so this is an example for third normal form normalization. We have a table like this. Now we have already seen this example. There is transitive dependency. That is, here the primary key is SSN. So the non-prime attributes are E name, birth date, address, D number, D name, and D manager SSN. So as per definition, no non-prime attribute should be transitively dependent. So E name to SSN, there is no transitive dependency. Birth date to SSN, there is no transitive dependency. Address to SSN, no transitive. The D number to SSN, also no transitive. But D name to SSN, there is a transitive dependency, because SSN to D number and D number to D name exist. And D number is not a candidate key. As D number is not a candidate key of this relation. Similarly, SSN to D name number to D manager SSN is there. So SSN to D manager SSN, there is a transitive dependency. Here also it is a problem, because D number is not a candidate key of this relation, M department relation. So it is a problem. So we have to normalize it. So how to normalize? We have to decompose it into two. So we have to decompose it into two. So D number, up to D number, it will be stored here. Now if you check this relation, it is in third normal form. Here also we will form another relation with D number, D name, D manager SSN. Now these two relations are in third normal form because non-prime attributes are fully functional. There is no transitive dependency on the candidate key or the primary key. So here also the primary key is D number and there is no transitive dependency. So it is in third normal form. It is also in first normal form. It is also in second normal form. Second normal form means it should be fully function dependent. So all the non-prime attributes are fully function dependent on SSN. Similarly, all the non-prime attributes in this table, D name and D manager SSN, is fully function dependent on D number. Now it is in second normal form and also it is in third normal form also. So this is a summary what we have learned. First normal form, relation should have no multivalued attributes or nested relations. So forms new relations for each multivalued attribute or nested relations. So that is what we have done there. In the case of second normal form, for relations where primary key contains multiple attributes, no non-key attribute should be functionally dependent on the primary key. So if there it is a case, then decompose and set up new relation for each partial key with its dependent attributes. Make sure to keep a relation with the original primary key and any attributes that are fully functional dependent on it. Then we have third normal form where relation should have a non-key attribute functionally determined by another non-key attribute or by a set of non-key attributes. That is, there should be no transitive dependency of a non-key attribute on the primary key. If it is there, then we have to decompose and set up relations that include the non-key attributes that functionally determines other non-key attributes. So that's what we have done here. These are the non-key attributes. We split it into another table and we form that table. So this is known as third normal form, up to third normal form normalization. So this is a reference. So this is very important. You have to learn this summary. You have to understand it thoroughly for the next assignment. So you have already mapped the ER into relations. Now we have next part of assignment is to check whether those relations are in first normal form, second normal form and third normal form. If it is not there, you have to convert it into first, second and third normal form. So this is a reference. Thank you.